This episode of the HVAC School podcast is made possible because of the generous support of our sponsors, RectorSeal, Carrier, and Mitsubishi Comfort. And I just want to mention real quick for those of you who are contractors or technicians, that one thing you may not realize, and this is certainly true with Carrier Enterprise Florida, which is the supply house that we use to get our Carrier products and a lot of our other supplies, there's one right around the corner from us, is that when you interact with your local supplier, you can often get products that they don't have on the shelf. And sometimes, as long as you can show that you buy a decent amount of them, you can get them to stock products that maybe they weren't planning on having. And I found that to be very true with our local Carrier Enterprise. Our territory manager is a really great guy by the name of Greg Schmidbauer, and his leadership team has been really great at working on getting the products that we need. And one of those products is the RectorSeal UV wrap, which is the wrap that we use for line sets. It's a non-adhesive wrap, which we like because it's easier to get on and off. It doesn't make a mess, and it does a really good job of protecting line sets from deterioration from UV, the tubing insulation. So, little plug there for both of those organizations, RectorSeal on their wrap, and then also Carrier Enterprise for working with us to get products that maybe didn't have on the shelf in the first place. And I would just encourage you, if there's something that you see out there in the industry that you would use, talk to your local supply house. If you have CE in your area, talk to them and see if they would be interested in carrying those products. And you may find that it's a win-win for both you and them.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
This is the guy who gets excited whenever he learns something new about HVAC, which is every day. Which means he is always a little too excited, for a grown man. Brian Orr.
Yes, this is definitely true. I do get a little over anxious sometimes, a little overexcited when I start talking shop talk with people about this industry. And whenever I learn something new, it is always a good day for me. And hopefully today will be a good day for you because you found the HVAC School podcast, which is the podcast that helps you remember some things that you might have forgotten about the HVACR trade, as well as helps you remember some things you might have forgotten to know in the first place. And today on the podcast, we have one of my favorite experts. Dick Wirz is the author of Refrigeration for Air Conditioning Technicians, Commercial Refrigeration for Air Conditioning Technicians, a great book, a book that you should definitely have if you do any commercial refrigeration. And I wanted to talk to Dick about defrost and some different considerations with defrost, and he was willing to come on. We had to bump it back a little bit because he got a sickness, like so many of you are suffering with right now. So if you're suffering with the flu right now, I feel your pain, but hopefully you can help break up your suffering by learning a little bit about defrost for commercial refrigeration. All right, well, thank you for coming on the podcast again, Dick.
Thanks for having me.
So I just wanted us to kind of start by going through just some of the basics of what are some of the different schemes that are used in defrost in the refrigeration industry that's a little different than air conditioning.
Okay, first off, air conditioning is operating, assuming a 75-degree return air, operating at an evaporator temperature that's going to be about 35 degrees below that return air, so it's around 40 degrees. So at 40-degree evaporator temperature, there's not much chance of getting any frost on the coil, except if you have airflow problems. But in refrigeration, we're dealing with, let's say, a walk-in refrigerator at 35 degrees is going to have an evaporator temperature about 10 degrees below that, 10 to 15 degrees below that. So we're down to 20-degree evaporator temperature, and definitely that's going to start forming some frost on the coil. That being the case, assuming a normal cycle, and there's no such thing as normal, but let's just say a normal cycle of 4 cycles per hour, that's a total of 15 minutes. And how it, in a perfect world, would come about is that you'd have 10 minutes of refrigeration and about 5 minutes of the compressor being off. Now, in commercial refrigeration, we keep the fans running on medium temperature units because that's important while that compressor's off to bring the temperature of the evaporator back up above freezing. So let's say that it's a walk-in refrigerator. We have a 35-degree box temperature. We have a 25-degree evaporator. And at the end of the cycle, we have built up a little bit of frost around the tubing. It's hard to see it, but there is a little bit of frost there. The compressor shuts off. The evaporator temperature, or the temperature inside the tubing, starts rising up to 30 and then closer up to 35. It is above freezing at that point. That frost is going to melt off. And then about that time, the thermostat calls for cooling and the compressor comes back on. Relating it back to air conditioning, we deal with a thermostat that's trying to maintain room temperature within 2 degrees because our bodies are very in tune to differences in temperature around us. However, in commercial refrigeration, we can have a wider temperature difference allowed because there's nobody in there that we have to worry about. We just have product. So the temperature in there is going to vary, usually 4 to 5 degrees. So when it shuts off, the box temperature is down about 4 to 5 degrees. The box temperature will come up 45 degrees. So you've got this spread in there that allows for defrosting of the evaporator. And that's basically it on medium temperature. And in a perfect world, you won't have any problems. However, sometimes because of opening the door or putting warm product or some other reason, we start building up too much frost on a walk-in refrigerator or a reach-in box. In those cases, we go from what would normally be termed an off-cycle or random defrost to a planned defrost. The planned defrost, we use a time clock. And this time clock, all it does is shut the compressor off for some time during the night when nobody's there. And that allows for extra defrost. Most of the time, it would shut that compressor off for about an hour. The fans would continue to run, and any frost that was built up over the day would be melted at that point. And this is something that the technician is going to have to verify the following day to make sure that was taken care of and the box temperature didn't get too high.
A couple things that I wanted to check with you, though, is that it seems like it would be very important in this refrigerator cooler type of application, this medium temp application, that the size of the unit is sized appropriately so that way it isn't running too much. Whereas in air conditioning, we think, okay, we want a system that runs as much as it possibly can for dehumidification purposes. But in this case, we don't want a system that's going to run all the time because then it's going to have more trouble with defrost then, correct?
We have to have the compressor shut off at some time, relatively frequently, so that it does give it that off-cycle defrost. If it is improperly sized, and I hate to go to sizing because once you open up that Pandora's box, a technician is always going to be looking at, oh, maybe it's not big enough. More often than not, it's the usage of the box, whether it's a reach-in or it's a walk-in. Some kitchens, they don't have enough refrigeration space, so they keep running into the walk-in boxes, which are supposed to be just used for storage, and they keep opening the door, closing the door, and that's going to let warm air in there and infiltration to the point that we just build up a lot more frost, and we run the unit longer, which adds to the frost problem. How the customer is using it is very important when you're trying to diagnose why something has been freezing up.
And I get exactly what you're saying there. It's the same thing in air conditioning. As soon as technicians start to think everything's undersized, then that becomes the universal problem. So while sizing is important, a technician should be looking more at how is it being used, maybe if there's problems with door seals, for example, or maybe if they're leaving the door open or they're going in and out too much, or potentially maybe if they're adding too much new product at once and not kind of planning that out. I imagine that would also play a part in that.
It has a very big part in that. And I have a bunch of examples of exactly that being the problem and how we took care of it, but I don't want to go into that at this time.
That's medium temp. So you start with randomly, it's going to defrost itself based on its off time. The next would be that you time it, so that way it gives it specific time so that it can defrost. Are there any other strategies that would be used in medium temp in coolers and refrigerators?
Yes, it's what the thermostat is sensing. Usually in reach-ins, the manufacturers actually provide for a space in the evaporator coil where you slide the bulb of the thermostat in there. And the reason for that is we're sensing, rather than air temperature, we're sensing evaporator or coil temperature. And when the coil temperature gets down too low and starts causing frost, it will shut off. Not only will it shut off by sensing the coil temperature, but the thermostat rises in temperature with the coil. So the fans continue to run, and if it did build up any frost on that evaporator, the frost will be melted off before the thermostat can come back on. So that is the way that reach-in manufacturers do it. They use a coil sensing thermostat. Occasionally, we've had to do that with walk-ins, where instead of sensing air temperature blowing in the room or entering the evaporator, we'll actually use a thermostat that has a bulb, and we'll mount that inside the evaporator, and we'll do the same thing. We'll be sensing evaporator temperature, which will keep it off. Once it cycles off, it'll keep it off until any frost in there melts, and then we're back in business.
And so I imagine as you change that strategy, though, you also have to make an adjustment for a difference in temperature, right? Your target temperatures are going to have to change as well, depending on whether you're measuring air entering the evaporator coil or the evaporator coil itself, correct?
Yeah, not only do you have to change the temperature, but you also have to change the spread between cut off and cut on. So there's a little bit to do with that one, but hopefully I explained some of that in my book.
Yeah, absolutely, right. Once you get out of the medium temp zone and you start to go into actually freezers, low temp refrigeration, what do you see there? What are some of the different strategies?
Well, we have a completely different control setup, a different clock setup. This particular clock, we have to be able to more finely tune the adjustments as far as when it cuts in and when it cuts out. We start with a standard amount of defrost. And in the Washington, D.C. area, which I'm familiar with, it's relatively high humidity. And we end up with setting the time clocks for 4 defrosts a day. Let's say it's 6 a.m., 6 p.m., noon, and midnight. In a perfect world, when it goes into defrost, it usually will defrost in about 15 or 20 minutes. And then it comes back in to the freeze cycle. However, on these time clocks, when it has a defrost termination in the evaporator, if it's in for more than 45 minutes, it'll shut off. And you can set this fail-safe setting on the clock so that it won't go in any longer than a certain amount of time. The reason we have those in there is that, let's say that they're loading the walk-in box up with fresh frozen product and so forth, and the door's open and it lets in a lot of moisture and warm air. It's going to put extra frost on the evaporator during the next cycle. So the next time that it goes into defrost, it might take longer than that 15 to 20 minutes, but we don't want it to go any longer than the 45. So that's the deal with fail-safe. As far as the controls, we have controls mounted in the evaporator. So once it goes into defrost, a temperature sensor called defrost termination. And in a walk-in, that usually terminates when the coil temperature gets up to about 55 degrees. When that happens, it is assuming on an electric defrost that the coil is completely clear. It will bring on the compressor, but it will keep the fans off. There is a supplemental control, either a separate control or built into the defrost termination, called a fan delay. And in a walk-in, that's usually set for about 25 degrees. So the evaporator is going to have to come back down from the 55 degrees down to 25 degrees before it's going to bring on the fans. The reason for that is it gives the compressor time to get rid of any residual heat in the evaporator, and any moisture allows that to drip into the drain pan before the fans come on. If there is a problem with the fan delay, it will bring on the fans immediately after defrost. If that happens, it blows out a bunch of heat, moisture into the box, and we get snow happening, and it's a buildup on the fan blades and the fan shroud and so forth. So that is definitely a telltale diagnostic when we have a problem in a walk-in freezer where we've got all this snow and buildup of frost on the fans. It's just simply a defrost termination. Switch is bad. We replace that and we're back in business again.
So if a customer calls and says it's snowing inside my box, then you have a pretty good indication that that's what's going on.
Usually that's the case, yes. And of course the other is the gaskets on the doors or leaving the door open or so forth. That'll cause the same thing, but that's a little bit different.
So I wanted to talk to you for just a second here, just a couple seconds, about RectorSeal and a few of their products that they make for ductless systems. And we've talked about a lot of the different RectorSeal products, but a couple products we haven't talked about are their mounting products. So they make a product for mounting ductless systems to roofs. It's kind of like a stand that can be attached to an existing roof, in a flat roof construction, and that is called the Bigfoot product. They also make a product that kind of can sit on top of an existing roof, an asphalt roof or something like that, and that is called the Fix-It Foot. And so if you didn't know that those products were out there, well, then by golly, look them up. You can find all of them by going to rectorseal.com, and you can find their HVAC products page and look that up. They're really good quality products for both the VRF, VRV segments of the industry as well as ductless for mounting them on roofs. But another thing I wanted to mention, which this just recently happened, is we did an installation of a Mitsubishi ductless system down in the Miami-Dade market, which is down in South Florida, and they have these high wind conditions, and we used one of the RectorSeal hurricane rated or high wind rated wall mounts for this condenser. And that was all well and good, and we went ahead and did that. But then the inspector on the job wanted to see a certificate, an engineering certificate, showing that it was actually rated for that, and also a rating for the attachments, all of the different bolts that were used to connect the ductless system to the bracket and the bracket to the wall. And what I wanted to mention is that RectorSeal was really helpful. Between RectorSeal and Mitsubishi, they got us all of the different specs that we needed so that we could provide that to Miami-Dade. For those of you who have worked down in that market, they can be really tricky to deal with sometimes. And it worked out really good, and I'm thankful to RectorSeal and Mitsubishi for helping us with that. But also, just keep in mind, there are very few manufacturers, if any others, I'm not actually sure if there are any others, who make a high wind rated ductless mount. And even if you're not in an area that you have Miami-Dade force winds, it's nice to know that you have a mount that can work in those conditions, which means it's going to hold up to the most rigorous conditions. So that's RectorSeal, and that is their wall bracket, the Bigfoot and Fix-It Foot mounting brackets and stands.
There is another heater in there, and that is the drain pan heater. It's an interesting thing and forgotten by a lot of people that the drain only drains in defrost. And we have to wrap the drain line with heat tape. And we don't use a regular cheap heat tape. We use a self-regulating heat tape, and that costs quite a bit. I don't know what it is up to nowadays, $4 to $5 a foot, but anyhow, it's kind of ridiculous. But it's very important. That drain line has to have heat tape on it, and then it has to be wrapped in insulation to make sure that it's clear. So when it goes into defrost, there's a whole lot of water comes off that evaporator. It falls down into a drain pan. The drain pan has a heater that comes on to make sure that it doesn't form ice in the drain pan. The water goes down the drain and out to the floor drain or wherever it is. If anything happens to that drain line heater, it will back up ice into the drain pan and eventually up into the evaporator. The evaporator would be completely frozen up with ice. And that, again, is another diagnostic key. If you have refrigeration down, a frozen up coil, you have to check the drain line. Make sure the heater is working and that the drain is free of ice.
So just to kind of recap, when a freezer goes into defrost, hottest point in the entire box is going to be that evaporator coil once it's fully defrosted. And so we don't want to bring on that fan right away, because when that happens, you've got all this water in its liquid form. It's going to blow out into this box that should be well below freezing if it's working properly, which will then refreeze all over the place. And then also you're then would be rejecting that heat into the box. It's better to keep that heat in the evaporator coil, turn the compressor back on, delay the fan, and then you're pulling that heat back out of the evaporator coil, waiting until it gets down to a low enough temperature, and then bringing it back on. Did I summarize that correctly?
Exactly.
There's quite a bit of complexity that's added as soon as you have it in a box that's below freezing that you don't have when you're dealing with a refrigerator or a cooler. So you definitely need to discern the difference. Now, one thing that I wanted to also discuss is electric defrost nowadays. It seems to be much more popular, even when you're dealing with grocery stores and all that. But let's talk briefly about the difference between electric and hot gas and some of the considerations there.
Well, hot gas is when you're putting hot gas through the evaporator rather than heating up the evaporator by cal rod heaters that are just attached to the evaporator. And most air conditioning techs are familiar with that because hot gas is how we defrost our heat pumps. And it's done basically the same way. The only reason it's not used more is because it's more expensive. There are several ways to do it. Some manufacturers actually use liquid refrigerant, bypass the expansion valve, and run it right through the evaporator. And that warm liquid is enough to defrost the evaporator. Other ones use a third pipe that comes back from the compressor with hot gas and a valve similar to a reversing valve that puts a hot gas into the evaporator. There's a number of ways that manufacturers are trying to do it. But the upside of that is instead of having normally a 15 to 20 minute defrost time, you might have only a 5 minute, maybe 10 minute at the most defrost time. And that's very important because the time that you're not refrigerating that cabinet, you're raising the temperature of the cabinet and the product that's in there just a little bit at a time. That's going to affect the longevity of the product that you have in the box. So it's very important to get it in and out of defrost as fast as possible. But electric defrost is going to remain one of the popular choices just because it's a whole lot cheaper.
Cheaper, and also there's some other considerations too. When you're using hot gas, you have to be careful to not re-inject hot gas, straight back into the compressor. There's a couple different things you have to consider, in addition to the fact that you do have a little bit more expansion and contraction of the copper with hot gas. And that's something that's my friend Jeremy Smith, who comes on the podcast a lot, he's talked about how in grocery store refrigeration systems, you can actually get lines that move a significant distance over long expanses just because of that expansion and contraction from hot gas defrost. Is that something you've seen?
Well, that, and also the fact that just the distance between where the evaporator is and where that source of hot gas is, it's only going to be able to stay hot for so long. You run 100 feet from the condensing unit to the evaporator, it's just not going to be warm enough to do any defrosting. And it can recondense. So there's other factors there for sure.
Whereas with electric heat, it's literally just a matter of powering it up and waiting till it's done defrosting and then firing it back on again, which is certainly more simple.
Very simple, yeah.
So quickly, I wanted to address the basic timer that we see. It's a trade name, but we call it a Paragon timer, is a term that we use a lot in the trade, and how that works, because there's a couple terminals that technicians see regularly, and I think there is some confusion about that, and I just wanted to quickly go over that, if you don't mind.
The terminals that are set up on the Paragon timers, the standard of the industry has been the Paragon 8145-20. That's a 240 volt clock. And terminals 1 and 2 are always power coming in. There was terminal 3 was going to the heaters. Terminal 4 was going to the fans. There was N, which is a common terminal. And there's an X, which is the defrost termination, which clicks it back out of defrost and into the freeze cycle. The 8145-20s are going to be in the older model units, but they've come up with Paragon and Grassland and at least one other manufacturer who come up with the electronic time clocks, but they've kept the terminal designation the same. And they've done that just because it's some kind of continuity in the industry. People know what they're dealing with all the time. The older Paragons were mechanical time clock, or I should say electromechanical, where you have clicking contacts, a timer that turns and pushes a slide, really archaic anymore. The electronic ones are doing everything electronically, much more accurate, and have a lot more features than the old ones did. We could do a manual defrost with them easier. We can spread the times easier. And the new electronic clocks do the same thing, just electronically. You can't see it. In my book, I use the 8145-20 just to show how they operate, because it was easier to see a mechanical device in drawings than it was the electronics.
The root of it is a fairly simple concept. It's a very flexible clock, which I think is why it's been used for so long. You can do so many different things with it. But you have 1 to 3, which is essentially normally open when you're in operation in refrigeration, 2 to 4, which is normally closed, and then the X terminal. And I just wanted to mention real quick about that X terminal, because I think some technicians think of it like a signal or something, like you're sending a call to X, but really it's making a circuit. And so all you're doing is just making a circuit from one side to another through some sort of defrost termination thermostat. When you think about 120 versus 240, some technicians get that confused, but you're just going in between those two lines and completing that path to X, so that way it can actually energize that solenoid and kick it out of defrost. Is that correct?
Exactly. When first looking at the defrost on a walk-in freezer, it can be very confusing. I remember my first time, and it took me a while and help from a lead technician to finally figure it out. Once I had it figured out, there was no problem at all. And so I transferred that knowledge to the electronic clocks, and that wasn't any problem either. But it is difficult enough that whenever we did an install on a big job where the electrician was supposed to do the wiring, we would ask them, do not wire the time clock. And we'd tell them the number of wires, how to number those wires, and just bring it into the location of the condensing unit and the evaporator and the time clock and so forth. And we'd do all the connections, because they invariably wired them wrong. So rather than get into how these things are wired, just understand that it isn't that difficult. It does take a little bit of experience. And once you got it, no problem.
And it's like a lot of things, I think, when you talk to technicians about even something as simple as wiring up a capacitor or wiring up a compressor and understanding what each terminal does. And once you've done it, it seems so obvious, like, why doesn't everybody know this? But for somebody who doesn't have a grasp of it, you've got to work at it until you get that grasp. So for those of you out there who are maybe doing a lot of air conditioning, haven't done much in the refrigeration side, when you get to one for the first time, go through that diagram, pull out Dick's book, read through it, get familiarized with it. And once you get it once, then it won't be a problem anymore. But don't keep going without understanding what each terminal does and the different configurations that it can be set up with, because otherwise you're really going to be selling yourself short in understanding. Don't just rely on fancy electronics to do it for you. You really want to understand what it is you're doing.
Yeah, we had too many job electricians burn up $100 time clocks. We had to pay for them because the manufacturer wouldn't cover them under warranty, obviously, and the contractor said, well, I did it right.
Right.
All that stuff. But anyway, and then there's one other thing I wanted to touch on briefly, and that is the new demand defrost clocks, or the demand defrost setups that manufacturers have. Heatcraft and a number of other ones. What that is, it's a circuit board set up with enough controls that it determines when there is frost buildup on the evaporator. It puts it into a defrost and brings it out more quickly than a time clock would, because it brings it out of defrost based on temperature of the coil, air temperature. There are different things that it senses. And they use pressure transducers that will check the pressure that's in the evaporator. That's another sense of whether I have frost buildup and whether I have defrosted enough. So demand defrost is getting to be very popular. Like everything else that's fairly new, the technology is kind of expensive, and so it's not out there in all the units yet. But as more and more gets out there and the prices start coming down, we're going to see that. And once again, it's almost a plug and play. and we don't have to worry too much about figuring out everything about those circuit boards. Just like any circuit board, inputs versus outputs, and they're fairly easy to diagnose.
Yep, you just need to make sure the sensors are in the right places and that everything checks out, and then you're good to go, which for those of us who have worked on heat pumps, that's essentially what we've had in heat pumps all this time. I mean, for many years, we've had a form of demand defrost. There's still a time function in there, which is how often it actually looks at the sensors, but it's essentially demand defrost. So if you're used to working on heat pumps, it shouldn't be too difficult to understand how demand defrost works in modern refrigeration.
Yeah, it's another thing, too. I can't overemphasize the opportunities that are available. Manufacturers are coming into the supply houses and distributors and giving seminars on things like this all the time. If you're fortunate enough to be in an area where your supplier or distributor is into training, then please take them up on those training programs. Many of them are in the evening after work. Some of the more in-depth ones are during the day, and a lot of knowledgeable contractors are sending their people to it to keep them abreast of all this. But learn as much as you can. It's a whole lot easier and faster than learning by burning out time clocks and boards on the job because you didn't understand them.
And what I would also suggest is if you work on a particular type of equipment a lot, because a lot of technicians out there are going to find they specialize or they have a customer that has a lot of similar types of equipment, look up those manufacturers online, call the reps and find out what classes are available, because in a lot of cases you may even be able to travel out and take a couple-day class at one of their facilities and really get a solid grasp of these products. Here on the podcast, we talk generally about these topics just to sort of give you an introduction, but to dig a lot deeper into these topics, first off, get Dick's book, and we've talked about this on several occasions now, and I've talked about it even when you're not on the podcast, Dick, but that is Refrigeration for Air Conditioning Technicians. That's the best book on this topic. If you want to look up Dick online, you can just type into Amazon. It's just Dick and then last name Wirz, and you can find his books there. If you want to get one on the cheap, you can probably even find one used, but his latest edition is excellent. And I would suggest that you get the latest edition if you possibly can. Is there anything else coming down the pike with you in writing and anything that tech should be looking out for?
Well, right now, the thing that we're working on is a diagnostic app for commercial refrigeration. It's actually out there now for Android phones and for iPhones, available in the App Store. The name of the app is RefTech, REF for refrigeration, and Tech, of course, for TECH for technicians. And we've got 12 problems on there that are easily solved. And one of those problems is normal, which is a very important thing. After you finish your repair or after you do an installation, make sure that everything is working properly, run it through the program, and it'll tell you normal, and you're good to go.
Very neat, very neat. Yeah, so we've talked a lot on this podcast about MeasureQuake app for air conditioning, but this is sort of like that. I mean, this is for commercial refrigeration specifically. Dick's done a lot of work on this, and I've looked at it. It looks really great. I haven't dug into it as much as I would like to, but I would encourage you to go find that on the App Store. And if you just type in RefTech, you'll be able to find that. And for those of you who especially are new to it, just spend some time with it, because again, like any technology, like any app, it's going to take you a couple minutes to kind of get to lay of the land, and you spend some time doing it, and I think you'll find that it really helps you out there in the field.
Yeah, it's got an instruction button on there which answers a lot of the questions, but you can contact me directly at Teacher Wirz at cox.net. That's TEACHER, and my last name WIRZ at cox.net. And what we've got is about 12 different sample problems. Be happy to send those to you. Try them out. That way you don't have to wait for a unit to be down to test it on. I've got some samples that you can check out.
Well, that's very generous of you. Yes, so definitely take Dick up on that. I appreciate you taking the time to do this. It's always an honor. I'm a big fan of your work. Maybe we'll get you on again sometime.
Great. Can't wait.
Hey, thanks for listening to this whole podcast. I have one request for you, just one small request, and that is that if you have not been to HVACrschool.com and signed up for our daily tech tip emails, I would request that you do that. Now, I'm gonna make a confession. I do not send a daily tech tip email every single day. Sometimes I miss a day here or there because I'm actually trying to think about things that are applicable that I've worked on and dealt with, and generally I try to write fresh content. Sometimes I recycle something that's a little bit older, but it's always, I commit to you that it's always going to be something that is going to be meaningful to those of you in the HVAC industry. And so if you wouldn't mind signing up for that, that would be really great. And if you maybe know somebody who doesn't know anything about HVAC school, and maybe they're not a podcast listener, maybe they don't like this form, and there are some people like that. Some people just don't like listening to podcasts. Well, they can still consume some really good content, learn a lot about the trade by going to hvacrschool.com. There is a search bar that you can use to find any of the topics. You just type in a word and you'll find, whatever you're looking for. For example, if you type in WIRZ, you'll find everything that Dick has participated in on the podcast and with our articles. All of our old podcasts are searchable there at hvacrschool.com. And so share it with a friend. I would greatly appreciate it. So there are a lot of different fears in the trade, fears of falling, which goes along with fear of heights. There's fear of electricity. You've all worked with a guy who, is terrified of electricity, and, rightfully so, I guess. But I don't know if you've heard about the fear of giants. Yeah, there's some people who are afraid of giants. It's called fee-fi-phobia. Maybe I should cut it out with the dad jokes. All right, thanks for listening. We'll talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.